Greetings, ladies and gentlemen. Hope you are fine. This is additional mathematics, Addma. With me is a question which says, find in ascending powers of x the expansion of 2 minus x over 2 raised to the power 6. The question, ladies and gentlemen, is coming from a topic called binomial expansions. The term binomial means an expression with two terms. Bi means two. So, take for example, we have this one. Okay? X plus y. That is an expression with two terms. 1, 2. And this expression with two terms is what is called binomial. When I square this expression, when I square it, for example, I do it that way, the result that I'm going to get will now be called expansion. Hence, the topic called binomial expansion. So if I want to expand this, since it is to the power 2, I'll be able to say x plus y, another x plus y. That is the meaning. Then I'll carry out the expansion here, which will be x times x will give me x squared plus x times y will give me xy plus y times x will give me xy plus y times y will give me y squared. Then I would say x squared, these two are like terms, I can add them, so to be 2xy plus y squared. This will now be the expansion of this binomial. I hope we are together. Now there are a lot of questions that would want to answer. When you expand, you get your answer. What are you learning from this? One, you could say, and you could see that if the binomial expansion has a positive power, of course what we are dealing with here will have positive power, which is raised to the power 2, then the result that you are going to have will have three terms. If it is raised to the power 2, then the expansion will have three terms. 1, 2, 3. So look at this one. It is raised to the power 6, meaning the terms will be 7. That is one thing you can observe. Also, you can look at the behavior of the powers of these two terms. The first term, how is it behaving? Second term, how is it behaving? You can see that the first term will start with the same power, which is this one, and it will be reducing. Here, x to the power 2, here, x to the power 1, here, x to the power 0. That's the reason why you're not seeing it there. It will be opposite to this one. This one will start 0, y to the power 0. Here it increases 1, here it increases 2. I see that. Not only that, we can also study the coefficients. In the exam, they can ask you to just give them the last term or the second term without expanding. So there are a lot of things that we can talk about, but let us be specific with this question that we've been given. This one was easy because it was raised to the power 2. Now what if you are given an expansion, binomial expansion, which is raised to the power 30, to the power 12, to the power any positive power. Are you going to go on like this? To expand a binomial, we have two ways. Here we are expanding. Now we have two ways. You can either use what is called the binomial theorem or the Pascal's triangle. In this expansion, we are going to use the binomial theorem. Then we'll have another question where we can use the Pascal's triangle. Each has got its own advantage and disadvantage, and I'll be able to explain to you so that you choose the one that you feel is okay with you. The binomial theorem states that if you have A plus B as your two terms raised to any positive power, then the formula will be a to the power n plus, which will be the first term, plus n choose 1 or n combination 1, a n minus 1 b. Are you following? Plus n choose 2, a n minus 2b squared. I think that. Plus, it goes on and on and on. It goes on and on and on until it gives us a general formula, which is n choose r, a n minus r, b r, plus goes on b r. I'll be able to explain this part, whereby you can use this formula to get the specific term in any binomial expansion. So this is the binomial theorem or formula. This is the first term, second term, third term, goes on and on and on. Where you are going to end will depend on the power. Will depend on the power. So in this case, since it is up to 6, I'll be able to write. Okay? I'll be able to write, and it will now be a plus b power n is equal to an plus n1, n choose 1, an minus 1b plus n choose 2. Okay, so you should be seeing the way the numbers down here are increasing. Then a n minus 2b squared, we move on, plus n choose 3, a n minus 3 b3 plus n4, a n minus 4 b4 plus n choose 5, a n minus 5 b5 plus the last term now will be, the last term will be n choose 6, a n minus 6 b6. You see that? So I'll be able to end there. Number 6, I'll end. Then I'll just be able to substitute in this formula. Okay? Well, the expansion is this one here. So we need to know what we need to substitute in here. So looking at that expansion, which is 2 minus x over 2 the power 6. The first term is your a. So in here we have a is equal to 2. This second term here, together with the sign, is your b. So we have b, which will be, is equal to negative x over 2. That is our b. Then n is your power. N is my power here, which is 6. You substitute in the formula here, simplify, you get your expansion. So let's start. A is my 2. So I'll say 2 plus, so here we have plus, but my b has a negative there. I see that as a negative. So that negative and this plus here will give me a negative. So I can simply say 2 minus x over 2 to the power 6 will be equal to, now I start putting in my formula there. Okay? So a is 2, n is what? The power 6. So 2 to the power 6 plus n is 6, choose 1, combination 1, a is 2, be putting them in brackets when you are substituting. Here 6 minus 1, b is negative x over 2. This is my b. Okay? This is your b here. You get with the negative, together with the negative. We are done there. We move on, plus. Here 6, choose 2. Like that. Here 2 in brackets. Here 6 minus 2. Here negative x over 2, like this. There is a power here, plus here 6, 3, here 2, here 6 minus 3, here negative x over 2, here 3, plus here 6, 4, here 2, here 6 minus 4, b negative x over 2, here 4, plus here 6, 5, here 2 in brackets, here 6 minus 5, here negative x over 2, there is a 5, plus, I'll be able to write here, plus here 6, 6, here 2 to the power 6 minus 6, b, here negative x over 2 to the power 6. Supposed to be 6 here. The power 6. The power 6. Further, you are now going to simplify this. You get your calculator so that you reduce the number of terms. You get your calculator. We start. So we're going to say equals 2 to the power 6. So 2 raised to the power 6. Your calculator has got a power where you can, some calculators here has got this as the power. So raised to the power 6, you're going to get 64. So here you write 64. Before you write the sign, and you have to be very careful and get me very well there. This is one term. Look at this. It is one term. Another term here. Another term here. Another term. Are you seeing that? So, when I start here, it means I'm ending here. This is one term. So now, you look at this plus here, and this minus. So positive and negative here will give me what? Negative. So you write negative. You are done with the sign. Then next, you are going to use the calculator here. 6 combination 1, or 6 choose 1. So on your calculator there, you are going to enter this. That is 6 combination 1, from combination and permutation. So you enter this, it will give you the answer. So we're going to say 6 combination 1, the answer is 6. So this will give us 6 here. I hope we are together. We come to this, put it in brackets. This is 2 raised to the power, here to be 5. Okay, then in brackets we have, remember we have used this negative, so you don't have to write it. The negative was multiplied, so we got to this one. So here you remain with a positive x over 2. Okay, you have simplified a little bit. We come to this. Before you write this plus, consider this. Now here, there's an even number. So meaning, when we square this, the result will be positive. Have you seen? There's a 2 here. So meaning this multiplied by itself, the negative will be positive. So we have a positive here, meaning the result is positive. We have used this, remember. Then I come to this. I'll say 6 combination 2. 6 combination 2, the answer is 15. So this will give me 15, like this. Open bracket, 2 here. Here we are going to get 4. Then here you will be able to find the answer here. X squared, it will be x squared over, we have used this, so don't write it again. So 2 squared is 4, here 4. We move on to the next one. Before I write this plus, I have to check if I've got a negative sign here. Yes, here. Now this one is raised to the power, an odd number here, so the negative will remain. So negative, and this positive, I'll get a negative. Then I'll start. 6 combination 3. 6 combination 3 is 20. So this is 20. In case you don't know where the combination are coming from, it is the same as saying 6 factorial, which we write it in this manner. 6 factorial divided by 3 factorial, like this, okay? And remember, factorial means, when we say 6 factorial, we are saying 6 times 5 times 4 times 3 times 2 times 1. You get the answer, okay? So that is the meaning. So 6 choose 3 is 20. Open bracket. Here we have 2. Here we are going to have 3. Open. Remember, we have used this, so it will be x to the power 3 over, this one will be 8, because that will be 2 to the power 3, and that will be 8. We are done here. We move on. Before I write the sign, let me check. I have an even number, so meaning this will be positive. So positive will be positive. I start this. 6 choose 4. So 6 combination 4. This will give me 15. So this will be 15. Then open bracket. This is 2. Here I'll get 2. Here I'm going to get, I've used this, so it will be x to the power 4 over, here I'm going to have 16, which is 2 to the power 4, and that will be 16. So 16 here. Are we together? We are done with this. We come to this one here. I have a positive here, a negative here, and it is an odd number, so it will be a negative. Negative and positive will give me negative. Then I start here. 6 combination 5. 6 combination 5 will give me 6. So it will be 6. Then this, I have a 2 to the power 1. 6 minus that is 1. Then on the other side here, x to the power 5 over 2 to the power 5. What will be the answer? 2 raised to the power 5, it will give me 32. So I've got 32 here. Are we together? So the last term now here. The last term will be here. Will come from here. The last term. That last term, this is to the power 6. So this will turn into a positive. Positive, positive will give me positive. So I will say positive, I'll write it down there. So plus 6, choose 6. So 6 combination, 6, the answer is 1. So I'll get a 1. Then here I've got a 2 to the power what? 6 minus 6 is 0. Open bracket. This has already been used, the negative. So I've got x to the power 6. X to the power 6 over 2 to the power 6. What answer am I going to get? 2 to the power 6, 64. So I've got 64 here, like this. Okay? I will now be able to come back here and reduce the terms. I'll say equals 64 here minus, be careful here. Where are you going to start from? You're not going to say 6 times 2. No, there's a power here. So it will be 2 to the power 5 times 6. That is the format. So 2 to the power 5. It will be 32. Times 6 now. Times 6. You're going to get 192. Okay, so here you're going to get 192. Now, the 192 that you're going to get here, there's this one here. Okay, let me write 192. Then I've got x over 2. Like this. Then plus. Here, you're not going to multiply. First you raise the power here. So it will be 2 to the power 4. 2 to the power 4 here. You get 16 times 15. Times 15. 240. So this will give us 240. Then in brackets we have x squared over 4. Minus. Here you're going to say 2 to the power 3. 2 raised to the power 3. We're going to get 8 times 20. Times 20, you get 160. So this will give us 160 here. Then we have x to the power 3 over 8 plus. This will be 2 squared, that will be 4. Then 4 times 15. 4 times 15. That will give us 16. So say 60 here. Then we have this in brackets, which is x to the power 4 over 16. Minus. Here to be 2 to the power 1, that will still be 2 times 6, it will be 12. So 12 here. Then we have x to the power 5 over 32. Like this. The last term is here, plus any number raised to the power 0 is 1. 1 times 1 is 1. So I'll just remain with x to the power 6 over 64 at the end. further. I'll come back to this and do reduce them further, which will now be this expansion. I can now say 2 minus x over 2 raised to the power 6 is equal to 64 minus, we have 192 and a fraction here, so it means 192 divided by 2. Okay, 192 divided by 2, I'm going to get 96. So this will give me 96 here. Remember there is x, so I'll write x here. This is the same as saying 192 times this x over 2. If I want, I can say 1 over 2x. It's the same thing. Then I'll say 192 times 1 over 2, that is 96, then x. In case you're wondering where it is coming from. So we are done here. Plus, this will be 240 divided by 4. So I say 240 divided by 4. This will give me 16. So here I'm going to get 60. Remember there is x squared. X squared. Minus. Here it will be 160 divided by 8. 160 divided by 8. I'm going to get 20. So this will give me 20. Remember there is x to the power 3. X to the power 3. Plus, it will be 60 divided by 16. So 60 divided by 16, I'll get a decimal there, so you have to leave it in fractions. So in fractions, it will be 15 over 4. Then there is x to the power 4. X to the power 4. Minus 12 divided by 32. So 12 divided by 32, I'll get 3 over 8. So minus 3 over 8 here, x to the power 5. Then plus the last term, which is x to the power 6 over 64. There is nothing that can be done at this point, meaning this will now be your answer for this expansion. This is the way we use the binomial theorem in order for you to expand any given power. But remember, you might not know by heart, like I do, the binomial formula. We have another alternative of using the Pascal's triangle. And remember, this requires a lot of accuracy because this was just to the power 6. Now imagine if it was to the power 24. I've seen that? So we'll be able to look at how you can use the Pascal's triangle in such situation. I want you to observe this as well. It was to the power 6. Count the number of terms that we have here. 1, 2, 3, 4, 5, 6, 7. I see that? So when it is to the power 6, you expect 7 terms. When it is to the power 10, you expect how many terms? 11 terms, just like that. So in the exam, they can also ask you to find the term which is independent of x. Without you going through this, we'll be able to use the formula here to find the term that is independent of x. So in this case, the term which is independent of x is 64, the first term. This is the first term, second term, third, fourth, just like that. They can also ask you to find the fifth term without going through this. Just find term number 5, which is 1, 2, 3, 4, 5. They just want this term. So we'll be able to look at all those step by step. Thank you very much for watching.